So my next further drawing exercise on the parabola says this. Draw several parabolas with the same vertex and axis, varying the positions of S. That's the focus. Then draw a number of lines radiating from the vertex. This will illustrate the fact that all parabolas are geometrically similar. They have the same shape and vary only in size. Well, I'm going to do something slightly different. What I'm going to do is draw two parabolas and show that I can dilate one to get the other, and that will make the same point. So let me share my screen, GXWeb, and we'll get to work on that. So drawing the parabola with the focus, the way that Lockwood does it, draws a line from the focus to the x-axis. We can make that distance from the location of the focus specific, make that A, sorry, and I make the location of point B on the line a parameter t. We construct the perpendicular and take the envelope of that line as t varies. And that is our parabola. I'd like to change the limits so we see a bit more of it. Minus 10 to 10, reasonably. So there's this parabola. Now I'd like to create another parabola. Let me just hide some of this stuff. I'd like to hide all of that. So this parabola works with A. Let me create another parabola the same fashion. And call that distance B. And we'll put that at parametric location S along the axis and create a perpendicular there and create another envelope. It's S varies rather. No, that didn't do it. What's happening here? Create an envelope as S varies. There we go. And again, let's make S vary from minus 10 to 10. So here's our two parabolas. Again, I'm going to hide some of this material. And I'd like to take this parabola. This is the one that is attached to C. I can allow these to be dragged by unlocking parameters A and B. So now I can drag C if I like, and see how that parabola changes as we drag C. Obviously, if we put C on top of A, it's going to be the same parabola. What I want to do, however, is project one onto the other by dilation. Now, notice they both go through the origin, so I'm going to want to stick a point at the origin. I can do that just by intersecting those two, the x-axis and the y-axis. Now, what I'd like to do is I'd like to take one of these and dilate it and get the other one. In order that I can sort of identify what's happening, let me change both of these to a different color. We'll make them both gray, so we've got them sitting there. What I'd like now to do is try dilating this one by some factor to get that one. Well, let's just try that. So I'm going to use my dilation tool. That's this one here. I have to click on the center of the dilation, which is going to be the point E. And I have to specify what the factor of dilation is. I'm going to leave it as C so that I can just play with it. Okay, so there's my factor. Seen it's created something fairly close. That's a factor of 2 is pretty close to being the right thing in this case. It's a good guess by the system. What I can do here is slide C and watch that. Oh, look, there is a factor of 1 is on top of where it started. If I push it out to, let's change the limit here to 3 so I can get it up to 2. If I push it up beyond 2, I can see that I'm going to get it lying right on top there at a factor of 2.084 in this case. Can I work out what that factor would be? Well, I am guessing there's A and there's B. It looks about 2, so I'm going to change that factor from C, if I can select it here. I'm having trouble selecting that. There we go. I'd like to try that to be A over B. And there we see it goes right on top. Notice, by the way, that I actually changed the values of A. Let me just back up and see what happened there. No, I should change the value of B when I put that value C, and that's because A and B are unlocked. And so what it's going to do, it's going to actually change A and B in order that the value of C came as close to what it was sitting there. Short, make a long story short, if I lock them and then make that change C into A over B, then we won't get either of the grey parabolas changing. They'll stay where they were, and we can see that the scaled parabola sits right on top. And of course, we could check that symbolically if we wanted.